How computers work. From clicking our mouse to increasing the volume during our favorite song, we are constantly providing input to our computers. Input can be seen as the way we physically interact with computers. By interacting with various physical sensors, such as buttons, we give our computer commands, which are then translated into data for processing. How does a simple action like clicking a mouse trigger a computer to perform an action? First, we need to connect our input device to the computer via a physical port, typically attached to the computer's motherboard. The role of the input device is to detect and report events. For instance, a mouse detects a click. When the input device senses an event, it sends information to the CPU. This information must be in binary code, consisting of zeros and ones, to be properly understood by the CPU. Once the input is converted into binary, it is sent to the CPU for processing. Once we have data, it needs to be processed so our computer can understand and execute our commands. This task of processing information is handled by the Central Processing Unit, CPU. The CPU manages the interaction between hardware and software, effectively acting as the brain of the computer. It is responsible for facilitating communication between these components. For instance, when we adjust the volume on our speakers, the action's data is sent to the CPU. The CPU interprets this information and sends appropriate instructions back to the speakers. Similarly, when we run software, the CPU is tasked with executing all the necessary operations. Considering the vast array of software and processes available, the CPU's ability to quickly process and execute instructions is impressive. This efficiency is greatly supported by the use of computer memory. Our computers manage a wealth of information, but where does all this data go? Computer memory refers to the system or device used to store data, whether temporarily or permanently. The choice of storage hardware depends on how long we need to retain that information. Primary memory. Not all data needs to stick around forever. Sometimes, we only require information temporarily. Imagine organizing a party. You might temporarily remember details like the guest list, menu choices, and decorations while planning and setting up. Once the event is over and everything goes smoothly, you may not need to keep all those details in mind anymore. Similarly, when we run software on our computers, the CPU fetches necessary instructions from random access memory, RAM. RAM allows for rapid data access compared to other memory types. However, data stored in RAM is volatile. Once we close a program or shut down the computer, the data is lost. For instance, if we close a word processing application without saving, any unsaved work disappears. Secondary memory. When we upload 100 text file to our computer, we need a place to permanently store this data for future access. This type of data is typically stored on the computer's hard drive or another form of secondary memory. Once the CPU processes data and sends out instructions on how to handle it, output is produced. We can think of output as the computer fulfilling the command we gave it through an output device. If you're interested in learning more about CPUs, I invite you to join me in the upcoming video. We'll be diving deep into the intricacies of the Central Processing Unit, CPU, and its fundamental components. We'll explore the Central Unit, CU, which coordinates and manages the execution of instructions, and the Arithmetic Logic Unit, ALU, responsible for performing arithmetic and logical operations. Additionally, we'll delve into various types of memory such as random access memory, RAM, which stores data temporarily for quick access, read-only memory, ROM, used for storing essential system instructions, and the hard disk, a permanent storage solution for large volumes of data. By the end of the video, you'll have a comprehensive understanding of how these components interact to facilitate the smooth operation of our computers. Thanks for watching.